Properties of Rhombi, and we're going to be looking at pages 4 and 5. Question number 7-4, they want you to use the math notes from 711 that we did the other day and give the most specific name for each of the quadrilaterals below. So when we're done going over the rest of the notes, you're going to come back and do that with your groups of 4. Okay, go ahead and jump down to question number 5. And it says that Sally was analyzing rectangle ABCD to the right and noticed that the diagonals looked congruent. To test her theory, she decided to plot ABCD on a coordinate plane. The first thing for part A they want you to do is to plot these points. So A is at 0, 0. So for 0, 0, you don't go any right or left. You don't go any up or down. You just put a point right at the origin and label it with the capital letter A like I did. B is at 2, 0. So you're going to go 2 to the right and then none up or down. Just put your point right there and label it B. Point C is at 2, 4. So you go 2 to the right, up 4, put a point and label it C. And D is at 0, 4. So you don't go any right or left. You go up 4, put a point and label it D. Then they tell you to create the rectangle ABCD. So you go from A to B to C to D and then back to A to connect the whole thing. So the outside of this is your rectangle. For part B, they want you to draw in segments B to D. So from B, you're going to connect the diagonal to D. And from A, you're going to connect the diagonal over to C. Okay? Then in part C, they want us to calculate the lengths of BD and AC using the Pythagorean Theorem. Okay? Once we draw in a diagonal, it creates a right triangle right here and creates a right triangle right here. Okay? So to get BD, I used AB as one of my legs and I used AD as my other leg. That's going to give me the length of BD. I know that AB is 2 and AD is 4. I can count them because they're straight, right? 1, 2. Easy. Plug in a 2 right there. 1, 2, 3, 4. Easy. Plug in a 4 right there. The diagonal is not as easy to count because it's crooked. Okay? That means we are going to get a radical or decimal answer. So we're going to use that Pythagorean theorem to help us get it. So 2 squared is 4. And 4 squared is 16. We add the 4 and 16 to get 20. Then we go to take the square root of 20. So I looked for any perfect square factors of 20. I found a factor of 4 and a factor of 5. 4 has a square root. Square root of 4 is 2. Square root of 5 is going to give us this decimal. So as a simplified radical, we're going to write it as 2 square roots of 5. Part D says, what do you notice about the lengths of the diagonal? Will this pattern be true for all rectangles? This right triangle has 2 units and 4 units, so we would get the same answer of 2 rad 5. So we're going to say that these 2 diagonals are congruent, and then on rectangles, because you have opposite sides congruent and equal, then on any rectangle, you're going to have diagonal. Question number 6, which is now about Sally. Sally was so excited to find the pattern for rectangles, she decided to test the kite as well. So for this one, they want us to plot some points again. So A is at 0, 0. It's going to be right there. Make sure you label it A. B is at 4, 2. You go 4 to the right, up 2, put point and label it B. C is at 4, 4, 4 to the right, up 4, plot a point, call it C. And D is at 2, 4, so 2 to the right, up 4, put a point, label it D. They want you to take those 4 outside points and create your kite. Okay? Then for part B, they want you to draw in segments BD. So you're going to connect B over to D. That's going to create a diagonal. And then you're going to connect A to C, here to here. That's going to create another diagonal. Part C says calculate the lengths of BD and AC using the Pythagorean Theorem. Okay, so this one we need to do it twice because they're clearly not the same length, right? This one's way shorter than that one. So for BD, this one right here, we're going to use this triangle right here, which has a side of 2 and a side of 2. So I plugged in 2 squared plus 2 squared. 2 squared is 4, plus another 4 is 8. And when we take the square root of 8, we can simplify that radical down to 2 rad 2. Okay? Now to get AC, I used the big triangle right here, which has a side of 4 and a side of 4. So 4 squared is 16. Another 4 squared is also 16. 16 plus 16 is 32. And so the square root of 32, simplify that radical down to 4 square roots of 2. They're asking, are these two numbers the same? Is 2 square roots of 2 the same as 4 square roots of 2? No, they're not. So do the diagonals of kites have the same property? Meaning, are they congruent? They are not congruent, like they were for the rectangle. Okay? But it does have a different special property, and that's what we're going to do for part C. So for part C, they want us to calculate the slopes of BD and AC and see if we notice anything. All right, so for BD, we're going down 2 over 2, which is negative 2 over 2, which reduces to negative 1 over 1. And then for A to C, we go up 1, 2, 3, 4, and over 1, 2, 3, 4. 4 over 4 reduces to 1 over 1. These are what we call opposite or negative reciprocals of each other. So when you have slopes that are reciprocals, meaning the fraction is flipped, and opposite signs, one has to be positive, one has to be negative, and it doesn't matter which order, which one comes first and which one comes second, then you're going to have perpendicular lines. Okay? That's true for any two lines. If their slopes are opposite or negative reciprocals, they're going to be perpendicular. All right? Any questions? Question number 7 says, now Sally is going to see if the properties of rhombuses are similar to kites or rectangles. All right, so for part A, they want us to plot the 4 points again. So for A is at 1, 3, so you go 1 to the right, up 3, put a point, and there's your A. B is at 2, 5, so you go 2 to the right, up 5, put a point, label it B. C is at 4, 4, 4 to the right, up 4, put C. And D is at 3, 2, so you go 3 to the right, up 2, and plot D. Raise your hand if you graphed it correctly. Yay, good job, guys. All right, for part D, they want us to draw in the diagonals. So we're going to connect B to D, and we're going to connect A to C. That creates our diagonals. Part C, they want us to calculate the lengths using the Pythagorean Theorem again. All right, so first let's do B, all right, or BD, sorry. BD's right here. It has a triangle with a side of 3 and a side of 1. So we plug in 1 and 3. 1 squared is 1. 3 squared is 9. 1 plus 9 is 10. If we take the square root of 10, there are no perfect square factors, so we can't simplify that one. Now let's check AC. Here's AC. Same thing. Has a side of, this triangle right here has a side of 3 and a side of 1. We end up getting rad 10 and rad 10. Not a surprise, right? So we say, yes, the diagonals are congruent. And then for part E, they want us to calculate the slopes and see if they are perpendicular. Okay, so first let's count B to D. From B, we go down 1, 2, 3, and over 1. So we get -3 over 1. Now let's count A to C. So from A, we go up 1 over 1, 2, 3. So it's 1/3. Notice that they're flipped fractions, what we call reciprocals. 3 over 1, you flip it, becomes 1 over 3. One of them has to be positive, one of them has to be negative. Doesn't matter which one. This one could have been positive and this one could have been negative. You just have to have one of each, okay? Then you just say, yes, they are opposite, or what we call negative reciprocals, making them perpendicular.